All right, number 10, we want to use fundamental theorem of calculus to evaluate the following definite integral. All right, so we are looking to integrate from 0 to square root of 2 over 2, 8 over square root of 1 minus x squared, and they put the dx on top, but I'll just put it to the back, dx. Now, usually when I see something like this with a rational function, something in the denominator, I'm going to look for a trig function. Usually we don't deal with something to the negative first power, so let's just say if I had 1 over x minus 4. Let's just say that. And I want to integrate this. Well, usually I'm going to move this up and try to use a power rule. So I'm going to look at 1x minus 4, and I'm going to look at this as a negative 1. Well, when I use the power rule, remember I add 1 and then divide by that power. But negative 1 plus 1 gives me 0. Can't divide by 0, so I have to do some other method. So usually there's a special formula or something else we use. So I'm going to be looking at the trig functions. Usually those are one of those that have derivative that give me something like this, maybe the arc or inverse trig functions. So we're going to go to our cheat sheets and look at either derivatives to see which function, when I take the derivative, ends up being this. So when I go backwards and take the antiderivative, I get that starting trig function. So I am going to homework, cheat sheets and handouts, and then I'm going to go to the derivatives sheet, and I'm looking for, basically this 8 is just a factor I can pull out, so 1 over the square root of x, 1 minus x squared, something to that degree. Some function that I'll get 1 over the square root. Okay, right here, arc cosine. This is negative though, so arc sine right here, 1 over the square root of 1 minus x squared. It looks like this verbatim, just with a factor of 8. So I know that when I take this, I'm going to just pull that 8 out. Integral from 0 to the square root of 2 over 2 of this function. Okay, this integral is going to be equal to arc sine, which is sine inverse. So it's 8 out front. Sine inverse of x, and we're going to evaluate that from 0 to root 2 over 2. Now, we're going to be using the unit circle, but let me remind you of those restrictions when we're doing inverse cosine. Those are not some that we work with very often. So let me go back to our trig cheat sheet. And then we can kind of look at the restrictions so you know what we're looking at exactly. All right, so up here, it's showing us a little bit. Sine is equivalent to the y. And then right here it tells you inverse sine is restricted from negative 1 to 1. The range is pi half to negative pi half. So that is restricting us to the front half of the unit circle. So when we plug in square root of 2 over 2, that's going to land us here or here. But since we're looking at a positive y value, that's going to be the one in the upper quadrant. So square root of 2 over 2 for the y coordinate is right here. That's going to give us a pi rating of power 4 or 45 degrees. So just so we're aware, so when I plug this in, I'm going to have 8 sine inverse root 2 over 2 minus 8 sine inverse of 0. Now this is going to give me power 4 times this 8 minus 8. Now sine of 0, okay, the order pair is 1, 0 here. The y value is 0, so that's just going to give us 0. So it'll be 8 times 0 here. And then that zeroes out, so we get 8 divided by 4 is 2. So we get 2 times pi as our final answer. Now, I'm not sure how the calculator will handle this one, so you do want to be able to work these. It won't turn pi into a pi rational, so when you want to type exact answers, calculator wouldn't help you on this one, because it'll only give you a decimal form.